Hello everyone, myself Suryaji and my teammates are Saranar and Viswasujit. Our topic is recent developments in designing Internet of Things architecture. Our mentor is Dr. A. Vijay. We are from Sri Ramakrishna Engineering College, Coimbatore. Contents. First one, building an architecture, design principle, then an IoT architecture outline. Okay. Uh, Firstly, building an architecture. Uh, when creating a model for the reference architecture, one needs to establish overall objectives for the architecture as well as a design principle. That comes from understanding some of the desired major features of the result system solutions. Problem 2 solutions. The problem domain establishes the foundation of the subsequent solutions. The basic requirement is to create a model by the reference architecture. One needs to establish overall objectives. The architecture should be well designed. The design should be understanding someone or some of the desired major features from the past. Okay, then only then we should given the problem to solutions. Okay, then the domain established from the foundation for the sequence solutions. This is the protocol we used. The software engineer and principle includes. Okay, problem domain needs, problems, constraints. Application needs, turn, scenarios, requirement, business and technical constraints. This is solution domain. Concept-based technologies. Design objectives and principles, architecture views, needed capabilities and functions, technology components. System designs, development view, software components, hardware components are the system solutions. These are all the concept-based technologies. These are all the problems, constraints, needs. Okay. Design principle. Main design principles and need capabilities. The design and the principles is the main objectives. Okay. The cat is this is called a M2M or IoT solutions. Everyone knows M2M is a machine to machine communication and IoT solutions. IoT solutions is Internet of Things solutions. Okay, how it should be like what are all the problems are created in the project. It should be a machine to machine communication or IoT solution based communication. Okay, then only we can find out the problems and create the solution for the desired problems. Okay. Overall design objectives of IoT architecture shall be to target a horizontal system of real-world service that are open, service-oriented, secure, and offer trust. Okay. Design principle varied from the IoT based on the M2M solutions here. Designed for use of deployed IoT resource across application domains. Designed for set of support service that provide open service-oriented capabilities and can be used for application development and executions. Okay, the support service which we provide is should be open source, like open service oriented capabilities. Anyone can create or anyone can edit, develop, anyone can use it like that. Okay, uh, it should be IoT resources. Okay, it should be access IoT resources, and then to publish and discover resources should be known. Tool for modeling contextual information related to the real-world entities, capabilities that provides different level of abstracted and complex service, data filtering and analytics, APIs and SDK. These are all the design principles we have used. Then design of for sensing and actors taking on different roles of providing and using service across different business domain and value chains. First one, technology. Data and service presentation is second. Last one is service. Information and services and aggregation of informations. Okay. The fourth point, design for sensing and actors take on different roles for providing and using service across different business domain and value chains. This should be needs to be provided is a set of mechanisms that ensure security and trust, need to be authentication and authorization of access to use service as well as to be able to provide services. Requirement is the capability to able to do auditing and to provide accountability so that stakeholders can enforce liability if the need occurs. Fundamental requirement is to ensure interoperability. Fourth, design for ensuring trust, security, and privacy. That one like reliability, availability of services, security, and privacy. These are the trust, security, and privacy authorization. This design should be added for the purpose of reliability, availability of services, security, and privacy for the customer satisfactions. Design for scalability, performance, and effectiveness. Scalability aspects: large number of devices and amount of data produced. Performance: supervisory control and data acquisition. This is called SCADA. Designed for availability, heterogeneity, and simplicity of integration. Designed for simplicity of management. Designed for different service delivery models, that is cloud services. Each and every data should be saved in cloud for the future purpose and the progress. For instance, connected vehicles and software as a service. This is called SaaS as a delivery model designed for life cycle support. The life cycle phase are planning, development, deployment, and the execution management aspects includes deployment efficiency, design, time tools, and runtime. The IoT architecture outline. IoT architecture outline is there are three fundamentals used here. One is IoT data and services, then management, then security. These are all the three fundamentals used here. There are 7 layers in these IoT architecture outlines. One is business layer, then second one is application layer, third one is data and information layer, fourth one is service support layer, fifth one is communication layer, sixth one is resource layer, seventh one is asset layers. Okay. Uh, the asset layer, what is said is it is a strictly speaking not providing any functionality within a target solution. Then second one is application layer, third one is data and information layer, fourth one is service support layer, fifth one is communication layer, sixth one is resource layer, seventh one is asset layers. Okay. Uh, the asset layer, what is said is it is a strictly speaking not providing any functionality within a target solution, but represent a reason or justification for existence for any IoT actuators. Communication layer. It provides means for connectivity between the resource, differentiate between the notion of local area network and wide area network. Okay, this is the communication layer where we provide. IoT application benefits from simplification by relying on support service that performs common and routine tasks. One is a support layer that typically executing in data centers or service farms inside organizations or in a cloud environment, where the resource, communications, and service support layer have concentrated realization in terms of device and tags, network and network nodes, and communication servers. Okay, the what are all the sources, the network nodes and communication servers, like the tags. Okay, the data and information layers provide functions that capture knowledge and provides advanced control logic supports. Key concept. This is the key concept. Okay, here we provide key concept. These are all key concepts. Include data and information model and acknowledge representation in general, and the focus is on organization of information. Knowledge management framework as a collective term to include data information, domain-specific knowledge, actionable service descriptions. The application layer in turn provides the specific IoT applications, smart grid, vehicle tracking, building automation, or participatory sensing. This is term as PS. The final layer in our architecture outline is the business layer, which focuses on supporting the core business or operations of any enterprises, organization, or individuals that is interested in IoT applications. This will help to develop the organization by or the individual organization to get developed. Okay, uh, we the IoT architecture will support overall architecture outlines. Okay, customer relationship management, enterprises resource planning, or other business support systems. Okay, this is termed as CRM, ERP, DSS. In addition to functional layer, three functional layer group management related to system solution, which is related to its operations, maintenance, administration, and provisioning. These are all the management solution related operations. Okay. This includes management of device communication networks and the general information technology infrastructure as well as configuration and provisioning data performance of service delivered, etc. Security is about protecting of the system in information and services from external threats or any other harms. This is called security. If any threats from outside, it it will help to protect the systems and services. Okay. Uh, Basically, in IT sectors, there will be more external threats where where came. That's why we used security there. Security measures are usually required across all layers. For instance, providing communication security and information security. Okay, data and service processing. Basic event filtering and simpler aggregation such as data averaging can take place in individual sensors, nodes in WSANs. Contextual metadata such as location and temporal information can be added to sensor readings, and further aggregation can take place higher up in the network topology. More advanced processing is, for instance, data mining and data analytics that can be done in near real time. This functional group represents the vertical flow of data into acknowledge. Connected world with IoT. We live in connected world, not only in social. Uh, Conclusion. Summary of key findings. IoT architectures. There are three-level architecture models in the traditional architectures. Uh, this is a traditional foundation concept of IoT. Uh, it is used to simplify but effective framework. It provides a simplified data but given effective framework for the organization and the various components of an IoT systems. It uses three levels or layers to interact with its different nodes or devices. One is application layer, then one is network layer, and one is perception layer. This is three layer. Under the four layer architecture is application layer, network layer, support layer, reception layer. These are all the four layers. These are the three layers. SDN Docker-based IoT architecture. SDN Docker-based IoT software defined networking is defined as SDN, and Docker-based architectures are powerful technologies that can be integrated to create efficient and scalable Internet of Things. This combination allows for flexible and dynamic management of network resources while leveraging containerization for deploying and managing IoT applications. SDN control. The SDN control is the central nervous system of the SDN architecture. It is the main source. It is used for uh, given several connection to overall networks like a nervous system. It manages and control device linearly providing a single point of contact for network administration. The control can modify protocols to improve performance. It used to improve the performance, such as by implementing load balancing or traffic shaping. It's used for load balancing traffic shaping to improve the performance. It can also used to implement security policies such as controls list or firewalls. This is the SDN control. Switch 1, switch 2, switch 3. This is SDN control. On a gateway nodes, the switch 1, switch 2, switch 3 are supply the transmit the network to gateway and nodes through through these nodes. Uh, Recent developments in IoT architecture. There has been several recent developments in IoT architecture that are worth nothing. Some of the key recent development in IoT architecture we includes microservices architecture is an architecture emerging trend in IoT architecture. This architecture is designed to enable the development of complex IoT systems by breaking them into smaller, more manageable components. Cloud-based computing environment. This environment provides a scalable and flexible platform for storing and processing data. Autonomous software-defined network autonomous. Software-defined network is another recent development in IoT architecture. This technology enables the creation of self-configuring network that can adapt to changing conditions. Responsive application and IoT-driven agent-based systems. Responsive application and IoT-driven based system are also emerging trends in IoT architecture. These technologies enables the creation of intelligent systems that can respond to changing conditions and make decisions based on real-time data. The literature review encompasses a comprehensive exploration of various IoT architectures, includes three-layer and four-layered models, SDN Docker-based solutions, cloud fog architectures, and recent developments in the field. Three-layer architectures characterized by a perception layer, network layer, and application layer, emphasizes simplicity but may face scalability changes. Four-layer architecture introduces processing layer to enhance scalability and responsiveness, albeit with increased complexity. SDN Dogger-based architecture combines software-defined networking and Dogger technologies, providing a dynamic and scalable infrastructure with centralized control and flexible containerization. Cloud fog architectures integrate cloud and fog computing, distributing resources closer to IoT devices to reduce latency and improve real-time processing. This is used for real-time processing for improve the latency, cloud for and closer to the IoT devices, which is used in fog computing and cloud computing, etc. A recent development in IoT architecture emphasizes addressing security concern, optimizing scalability, and leveraging edge computing for faster data processing. Most important thing in this IoT architecture is about the security purpose and the scalability purpose, and the data processing will be faster than the other networks. These are all the best advantages and best advantages in the IoT architecture. Uh, I have told about what is IoT architecture and what are all the layers present in architecture and the design principles here. Thank you.